So today we're going to be doing a problem to find each direction vertically and horizontally at different times. So we have a ball at the top of a cliff traveling at 30 meters per second. So we need to figure out the distance in meters of how far it is going horizontally. So for this, all you need is the initial velocity, which is 30 meters per second. So if the ball goes 30 meters per second at 1 second, it is already going to be 30 meters horizontally. 2 seconds it'll be 60, 3 seconds it'll be 90, and 4 seconds it'll be 120. So after that, we already know the velocity initial, so we know the velocity final, which is also 30 meters per second. And we also know that the acceleration is 0 because it's going horizontally, so there is no push or pull. So we need to find the displacement of how far the ball is traveling, which we need to use the formula of velocity initial times time plus 1/2 acceleration times time squared. So the displacement, since we don't know time right now, this is just going to be a 0. So we have the initial velocity, which is 30, so we know that it is traveling 30 meters. Okay, so next what we need to do is we need to find the vertical. So in order to find the vertical, we know that the velocity initial is 0 meters per second because it's traveling horizontally. So that's why over here it's 30 meters per second, because the ball fell off the cliff going horizontally at 30 meters, but it didn't fall off the cliff going downward. So after that, we know that the acceleration is negative 9.8 meters per second because it's falling downward due to gravity. So we need to find the displacement, which is the same as before, velocity initial times time equals 1/2 acceleration times time squared. So we need to find at 1 second, 2 seconds, 3 seconds, 4 seconds, how far vertically the ball has fallen at meters. So we're going to use this equation right here to find how far the ball has fallen at 1 second, 2 seconds, 3 seconds, 4 seconds. So we're just going to plug in for each equation. So since the velocity initial is 0, this is just going to cancel out to a 0. So we know that 1/2 times negative 9.8 times 1, which is time squared, so 1 second times squared is just 1. So we know that this is going to be negative 4.9 meters. So over here we put negative 4.9 meters. And then we're just going to keep doing this for each different time. So for this time, it's going to be 1/2 times negative 9.8 times 4, since 2 squared, which is going to equal negative 19.6 meters. And we just keep doing this for each time. So next, it's going to be 3 seconds. So negative 9.8 times 9, which is negative 44.1 meters. And last is just 4 seconds, just the same as before. Just this time, it's going to be 16 in parentheses. It's 4 squared is 16, which gives you negative 78.4 meters. So next, what we need to do is we're going to find the displacement between the top of the hill and the bottom of the ground, just down here. So we're going to find this displacement. So this displacement is 30 meters per second, which we know is the velocity initial. We're going to use this equation right here. So it's 30 times 1/2, or 30 times 1/2 plus negative 9.8 meters. meters per second. But this is going to get canceled out because there's no time. So the final thing is 15 meters. Displacement. That's how you solve that.